This is the ATMOS node, a small environmental instrument with the soft, rounded silhouette of a vintage radio, the kind of object that feels familiar even if you've never seen it before. A single OLED acts as the instrument face, giving it a presence that feels both modern and slightly retro future. It doesn't blink, it doesn't chase your attention, it simply sits on your desk, steady and self-contained, quietly taking the pulse of the room. Temperature, humidity, pressure. Every few seconds, another reading, a tiny moment added to the long story your room has been telling all along. But the real sophistication of the ATMOS node isn't just in the data it collects, it's in how it's built. At first glance, it looks like a finished professional instrument, but it's nothing like the devices you're used to. There's no traditional circuit board inside. And despite how unusual its engineering is, getting your hands on one is surprisingly simple. All you need is a basic 3D printer, or access to one, to build this at home from a few simple parts. This isn't something you buy, it's something you build. Most people assume their room is stable, predictable, comfortable, but rooms have patterns you never notice. The temperature drop at 3 a.m., the humidity spike when you cook, the slow pressure shift before a storm, the way sunlight moves across the room, the heat that lingers long after the AC turns off. ATMOS node listens to all of it. Behind the cover, it quietly measures the environment every few seconds, temperature, humidity, and pressure, building a continuous record of how your room behaves. Not just numbers, patterns, rhythms, the subtle movements of a space you thought you understood. ATMOS node turns those invisible behaviors into something you can finally see. The OLED shows a clean, instrument-style interface. Pressure is displayed on the left, and temperature and humidity are shown on the right, all set against subtle grid lines in the background. It feels like a miniature scientific device. Simple, deliberate, and easy to read at a glance. But the screen is only the surface. The real story is in the data. ATMOS node sends its readings through MQTT, a lightweight way for devices to publish tiny messages. Think of it like a digital radio station. ATMOS node broadcasts numbers, and anything that knows the station name on the topic can listen. You can send that data anywhere: a desktop app, a phone app, a tiny database on your PC, a hosted MQTT service, or the live chart on my website. And when you first assemble it, upload the firmware and power it on. You can watch it working live on my website. Just add the topic shown in the Arduino code. The instructions are in the project section of my site. No accounts, no subscriptions, just data flowing. And because this is an open instrument, your data remains yours. Whether you stream it to a custom dashboard or choose to store it entirely locally, the ATMOS node is built to be a private, permanent record of your space. Open the enclosure and you won't find a traditional PCB. Instead, the circuit is built directly into the 3D printed chassis. It's a solid architecture of filament with precise channels carved through it to guide each wire exactly where it belongs. The wiring is no longer just a connection, it is part of the structure itself. Every module locks into a dedicated 3D printed socket with a clean mechanical fit. No copper traces, no solder, no chemicals. Just geometry doing the work of a circuit board, making electronics simple, repairable, and entirely buildable at home. The assembly is straightforward. Print the PCB body, push the wires into the channels, press the microcontroller into its socket, add the single sensor that integrates both the AHT20 and the BMP280. Mount the OLED, close the enclosure, a handful of components, a few wires, and suddenly you have a finished environmental instrument that looks like it came from a lab, not a hobby bench. If you want a closer look at how the wiring works, how the channels, sockets, and geometry come together, I've made a separate video that walks through the technique step by step. You'll find that link in the description. With a few days of data, you start to understand your room. With a few weeks, you understand your habits. With a few months, you understand the seasons. ATMOS node becomes a quiet diary of the space you live in, revealing comfort patterns, airflow behavior, insulation performance, energy use, sunlight cycles, and humidity rhythms. It's a tool for understanding your environment, and a reminder that even the simplest spaces have stories you've never seen. ATMOS NODE doesn't try to be smart, it doesn't try to be clever, it just watches, measures, records, and gives you the honest view of your room, clearly, quietly, and without noise. If you want to build one, everything is on my website: the enclosure, the wiring map, the firmware, and the live chart that shows your data the moment the device comes online. A small instrument, a quiet observer, a window into the space you live in. Most environmental monitors are cloud-locked, closed, disposable, inaccurate, or visually uninteresting. ATMOS NODE is different. It's the antidote to vendor lock-in. No cloud you don't control, no data you don't own. It's accurate, it's repairable, it's printable, and it gives you ownership of your data. It's a desk instrument you can understand, modify, and rebuild. A tool that feels finished but remains completely yours. And if you want to see where this philosophy came from, how this approach to open, printable instruments took shape, I've made a separate video that tells the full story. You'll find it in the description. If you have a 3D printer, or access to one, you can download the files, the wiring map, and the firmware from my website. Assemble it, flash the code, power it on, and watch your room emerge as a live graph, a quiet stream of data that reveals the story of the space you live in. This node is part of the Vanguard Tier, a growing family of applied instruments. If you want to explore the other nodes in this tier, the links are in the description. If you want to follow the evolution of this system, consider subscribing. And if you know a fellow maker who would appreciate this design, feel free to pass it along. Thanks for watching. I hope this inspires you to build tools you can understand, repair, and truly own.